Okay, cool. Yeah, I hope you're all doing well out there. And yeah, I would like to be in front of you on a stage presenting these slides, but yeah, unfortunately, it's not possible today. But I hope this suits you well. So I would talk a bit about serverless with AWS Lambda and Python. And so first about who am I? So I already introduced myself. My name is John. I'm a DevOps data engineer working for an energy company based in Leipzig, but I'm originally from Berlin. And in my spare time, I'm doing full stackish, mainly focusing on front-end technologies. So I'm usually reachable via all this known social media, so you can find some of my works there on CodePen, on GitHub, and you can always reach out to me and I try my best to answer all your questions. So today's agenda. So first of all, I would like to say thank you, PyBerlin, for the opportunity. And also, this talk is it's not addressing a particular group. It's you can be beginner in serverless, and I hope I will not do it too complicated. I'm trying my best not to overwhelm you, but you can also be familiar with serverless technologies, and I hope I still can offer you some new tricks and learnings. So first of all, I would talk a bit about what is serverless, the benefits and limitations. Then we will focus on AWS cloud services. And then we will dive deeper into AWS Lambda, how it looks like on the AWS console. We will also create a first serverless function. And then we will use some known frameworks to deploy some Flash application or Django application. So first of all, what is serverless? So serverless is a rather controversial question because obviously there are servers. So you cannot live without servers to serve your web page. So I always think about, or I always say you care about serverless. So the term serverless wants to abstract the underlying infrastructure and all the ops tasks, which you probably might have in setting up a server. It is pay as you go, so you pay only the execution time. So I remember back then when I was back then I bought a server for €5 a month, and I was actually barely using it and still I was paying for it even though I was not using it. So with serverless, you really only pay the execution time. And then you don't need to worry about scale in and scale out. So the €5 server I bought back then was a small server just for some scripting, some testing. But if you really want to scale out, you need to buy bigger machines. And back then you needed to spend a lot of money to just have a server running. And now with serverless, you don't need to worry about the scaling. So that means when you have a high traffic on your web page, it's automatically scales out for you. And if the traffic is not that high, then it scales in for you. It is always high available, meaning it is always high available like your cloud provider. So nowadays, all the big IT companies like Amazon or Google, they needs to be available 24 hours. And so that's why serverless are always high available. It is developer friendly. It means you are not particular stuck into one programming language. So now you have many programming languages which support serverless. So that means, yeah, it is developer friendly. So you can choose your programming language of your choice. So these are all the benefits. Now, speaking of some limitations. So as a DevOps engineer, it increases a lot the tool chain. So you need to have a lot of, or a broad tool set in managing the application. And you also need many different tools for monitoring or troubleshooting your serverless function or serverless service. And so it can be somehow also overwhelming. In terms of machine learning, for example, you cannot use a function as a service because usually the machine learning libraries are quite big. And so it is also not the best use case to use machine learning for a function, serverless function. Actually, I wrote a blog post on dev. So my pain with serverless, especially in Python. And yeah, we will share the link later, so you can click on this and see my pain in there. So speaking of different services, serverless cloud services on AWS. So there are already well-known services like for storage, we have this S3. S3 is the Dropbox of AWS, I would say. So you can store your objects in there. You don't need to worry about the capacity or how many megabytes do I need or gigabyte do I need for my objects. So you just drop your files in there, and then there are other services like Pleasure or the EFS. Later on, we would dive into AWS Lambda, but the services you see here, those are the services mainly I work with, but I'm pretty sure I'm missing some. Fargate, for example, is like the serverless Docker service of AWS, so you don't need to manage underlying servers to host your Docker image. And then we have serverless database like DynamoDB, which is the NoSQL service of AWS, and Aurora, which is the relational equivalent of DynamoDB. So, okay, but we were focusing on AWS Lambda, and AWS Lambda was introduced in 2014 on the reInvent. So here in the background, you see the video, a video of Werner Vogels, who was introducing AWS Lambda. And from that moment on, it completely changes the way of architecting an application. So now you have like just a single function, a single compute unit to build an entire application or entire ecosystem around your application. So AWS Lambda so they advertise it as one code without thinking about servers. So it is an event-driven smallest serverless computing power, which is managed by AWS. The equivalent of Azure is Azure Functions, or on Google Cloud, Google Functions. And so AWS Lambda allows you to abstract your business logic, so that you just focusing on your business logic instead of managing the operation, the tasks which are coming from the AWS Lambda. So it is of the role, or we can classify as in the role of computing, and it comes with different runtimes. So it is very mature in Node.js and Python, but there are also runtime for Java, Go, and C#. And you can also create your custom runtime. So you can, if you have a PHP, for example, or you want to create your function in PHP, you can use a custom runtime and then run your function in PHP. So as I already mentioned, it was introduced in 2014. Python, by the way, is the most popular runtime of AWS. So let's see how it looks on the AWS Management Console. So we have here the AWS function tab, Lambda tab. So I will create a new function, and so in here you can already start starting from scratch, or you can use one of those blueprints which are already available, so you don't need to code. For example, here you can get, or you have a Python function which gets an object from an S3 bucket. But for now, we will create a function. We call it PyBerlin demo, and we choose the Python runtime 3.8, and then hit create. So you could actually also create a permission on that, but for now we let AWS creating a permission for us. So, and then you have already an editor inbuilt in your browser where you can already start changing. Hit save, and you can also even test it. So, and test it when the first time you want to test it, this pops up where you can start choosing your trigger. So for example, your Lambda function needs to be, or wants to be executed whenever a new entry in the DynamoDB table has been made. So this is actually the JSON format, how the stream of the DynamoDB table is floating in. So you can really test your Lambda function against this trigger or this input. So for now, we stick to the common one, the hello world, which is a custom JSON input. And we just leave it like as the default. Oh, we need to give it a name. Hello. And then we can also already start testing it by clicking on that. And we get a result like the logs in here, which gives a status code 200 and the body hello Berlin. Awesome. Okay. So we did this. Speaking of triggers, so I already mentioned that we have different triggers. So I was talking about the DynamoDB trigger. So whenever a new entry in the table is made, then this Lambda function is executed. But there are several options. So you don't have You don't just have, or you have many triggers where you can choose from. What is very interesting is you can also choose one of those from the partners. So Datadog is maybe quite interesting, or MongoDB if you don't like the DynamoDB table. But yeah, you have many choices to use your trigger. The most common one is the API gateway, but we will talk about that in a minute. So back to the slides. So around all this AWS Lambda, so it is nice to create a function and you can do it directly in the browser, but it is also kind of cumbersome. So there are frameworks or tools where you can create your Lambda, or you create several Lambdas with just one click, or you set up a framework which is doing all this task for you. The most common one is the Serverless Framework. It is open source and it helps you to build serverless application on different cloud vendors. So it is not only on AWS, but also Azure, Google Cloud, Alibaba Cloud, and so on. It supports also many other different languages, not only Python, but also Node and Go, PHP, and so on. So for that, I have created a template on GitHub. So it's called Serverless Flask, and we will just a sec. We will now create a serverless function using the serverless framework from scratch. So for that, you need to have at least Node installed, not npm, but Node. And if you have Node 10 point something installed, then you can start with npx, or then you have npx out of the box. So I hope you see all my terminal. So let's put that into your terminal. What it does, it's using my GitHub repository, and it's creating a folder called my Flask app. And now we are going into my Flask app, and we have already some files in here. So the serverless framework is written in Node. So that's why it comes with a package JSON. And yeah, what we can do is now, we already did the CD, but we need now to set up. We need to install the serverless framework. And with this template, you get prompt and asked how you want to name your service. I'm going to name it PyBerlin Flask demo. I'm choosing the current Python runtime 3.8. I want to deploy it in the European Central 1 region. I don't want to use Docker. And I don't care about my custom domain name. And that's it. So now you just need to hit npx serverless deploy, or if you have installed serverless natively, you can use this command, or actually it should work if you just take this command and then hit Sls Deploy. So what it does now, it using the requirement txt, which was in the package, and it now spins or sent this function to AWS. So how does it look like? So under the hood, the framework creates a CloudFormation stack. So you can think of infrastructure as code, meaning in here you find all the resources which is created by the serverless framework. So it creates a deployment bucket and a deployment bucket policy. It has been created created completed. Okay, let's just wait a bit. You can also check out the S3 bucket. So you see they have created serverless folder for you, and then the name of your serverless application. And in there you will find a JSON file, which is your CloudFormation script, which contains all the underlying infrastructure for you. Okay, cool. So this is now had been executed, and you will see here an endpoint. So if you open this endpoint, now you have your Flask application on the cloud. So let's go back to the console, see. The PyBerlin demo was the first Lambda function we had been created in the beginning, and the PyBerlin Flask demo was just created. And we can see it has an API gateway. So that's why we have now an endpoint on AWS, which you can easily call and which points you to your Flask application. Okay. So now let's update this. So for that, I will open VS Code and I will, so what is here? We have now a Flask function endpoint, which is directing to the index HTML. Now let's create a new template. We call it user.html. We removed all this. I have prepared something for you. So if you're familiar with Flask development, then you will probably notice I'm using Jinja syntax in here. And I will also modify my app PI with this code snippet. So what it does, it create a new endpoint user for you. And if you put a name after the slash here, you will get the result, or it will yield your name. So, okay. So we have updated now the app PY. We have also updated the user HTML. And now we need to deploy it. So gonna deploy it when we hit Sls Deploy. And the framework already knows what to do. And let's see in the console what's going to happen. On the CloudFormation stack, you see, oh, it already had been updated, completed. But in the terminal, not yet. Yeah, but last modified 3 seconds ago. Cool. So what we can see now, if we open this Flask application again, yes, we see the index HTML. Now we can create user or go to our new endpoint user and say, for example, John or PyBerlin. And yeah, according to what we give here as a parameter, we update the value inside the HTML. So that's an easy way to get started with a Flask application on the serverless framework. Just don't forget, once you have created your function, your AWS function, just remove it, because the endpoints are publicly available, and there are evil bots out there which are crawling all the AWS endpoints, and you don't want to wake up with a huge bill because it was executed several of times. Okay, so we're going to remove the stack, and now it should be gone from our console. We are also going to delete this first created function. Just a quick check on the S3 bucket. It's gone there. CloudFormation stack is also gone. Great. So we have removed our serverless function. Then there's another framework called Zappa. And Zappa is Python made. So it feels more natural if you're developing with Python using Zappa. And for that, I have also created a template. So it is made with Cookie Cutter. So you need to have Cookie Cutter installed. And then you can use my template from the GitHub repo. So let's go check that out. I'm going to go back. I'm going to use Cookie Cutter. So it will ask you the project name. Again, PyBerlin, serverless. Let's create automatically a Slack for you, a project Slack for you. Hit enter. So my name is John. And this time we're going to create a Django application. And it will also create a S3 bucket for you with this name, PyBerlin serverless John. Okay, cool. So now we need to go into the new created project. So yeah, and now we can start developing or putting our Django application to the cloud. So for that, we need to create a virtual environment first. I assume you are all familiar with the virtual environment. And we need to activate the virtual environment. Now we have our virtual environment. Sometimes it's good to upgrade your pip, your package manager for Python. It was good that I updated it, because now I'm on 21.1. Cool. So for executing or installing all the requirements, maybe just a quick look what we have here. So we have Django in there. We have Django S3 storage in there because we want to, or we would like to put our static files into an S3 bucket. So we need like sort of a package for that. And then we have Zappa. which is doing all of the serverless work for us. Okay, so let's install these requirements. And this I can close for now. And then we have a single command which deploys our application to the cloud. Great. Let's use Zappa deploy dev. So under the hood, it's also creating a CloudFormation stack. It's packaging this into a zip file, and now it's shooting the zip file to the cloud. So we can check that on the console. Wait. Yeah. So this is our serverless function on AWS using Zappa, and it's done. So we also get from the API gateway a URL. So if we click on that, we get first an error message which shows that we have not configured Django properly. But this is actually a good sign because we can see it here. It's using Django 3.0, 3.06. And now what we need to do is configure this. So back to the slides. So we see this. Django now is blocking the AWS URL host. And that means we need to configure that in our settings.py. So going in here, in the Django project, we have our settings PI here. And in here, we have the allowed host. You see there's nothing yet, meaning we need to take this URL. Wait. Yep. But without a def in the end. Oh, yes. Okay. So we save that. No formatter. And then we need to update our project. So going into our terminal using Zappa update, and it now updates hopefully our serverless function. So you already see here it's creating a zip file where it packaged all these files into it. So let's go to the console. Yeah, it's still uploading. So what is maybe worth to mention is if you're familiar with Django, then usually Django comes out of the box with a database, with a SQLite database. I have disabled that because AWS is not using a SQLite database. So you need to think about a different way how to connect it with the database. I think Django can only use a relational database. So Postgres, MySQL are a good fit for that. I'm not sure about DynamoDB, to be honest. But so, well, it was updated. And now we have to do one more thing. Because if we open this again, oh, now we have to do, okay, I'm a bit confused, but let's move on. Now we need to let Zappa managing our static files. So with this command, it will put the static files which are coming from Django into the S3 bucket. Static files which are coming. So when we use this template, we have created two S3 buckets. So this S3 bucket is where the files of Django's will be stored. So now you can already see the admin files are put in here. There are no complaints for now. It's just showing some debug information. And let's call this URL again. And did I do that? Okay, that's sorry, I needed to put this instead of the HTTPS, so only the host name. So I'm very sorry. So we have to do it all again. So yeah, and if you want to develop it locally, you usually go for 127.0.0.1, I guess, to have it on your local machine. And I hope this will be fast. And I'm super sorry for that. Okay, now we're live again. Okay, that's a better output because now we have a page not found, because in the S3 bucket we don't have an index HTML of Django yet. We only have this admin page. So if we are calling now the endpoint admin, we have our Django application on AWS using AWS Lambda. And as I already said, it is not connected to a database yet. So meaning there are no users yet. But if you go to my project in here, there's an instruction where you can create an RDS on AWS, like a Postgres database or MySQL database, and then connect it to your Django application. I will leave it like that for now. And just don't forget to remove your work after you have deployed. So now we're gonna undeploy this application. And what is actually a disadvantage in using Zappa, it's not removing the S3 bucket, which had been created. So that's why I have created a small script here where you can remove your S3 bucket. Okay. So you have seen two frameworks in action, the serverless framework and the Zappa framework. So so I'm going to summarize the advantages and disadvantages of both of them. So the serverless framework has multi-vendor, so it's not only AWS, but you have to know that serverless framework is it's a bigger company, has several people working on that. So that's why they have the possibility to have to support multi-vendors. So that means also you can do like multi-cloud deployment. It is easy and fast to set up. It has many plugins, really a lot of plugins. Not all of them are usable, but there are some really good ones, especially for TypeScript. You have YAML support out of the box, which you can extend with CloudFormation. It supports many programming languages. So as I already said, so Node, for example, or Go, Java. But it is written in Node.js and not Python only. So that means you need to do many configurations to make it Python ready. So if you use my template, then it's already Python ready. But if you're starting from scratch, then you need to do a lot of configuration in setting up a Python application. Zappa, on the other hand, is Python only. Now you can argue whether that's good or not. It was super fast to set up an application, a Django application. Django is like pricing the 5 minutes of setting up their application. And with Zappa, you are, I would say, less than 5 minutes, and the Django application is up and running in the cloud. You can also easily migrate your WSGI application. So not only Django, also Flask or Falcon, I think it's also WSGI application. If you have already one of those up and running and you want to move to the cloud, you can use Zappa, and it's quite straightforward to shoot them into the cloud. Then now you can again argue it's only on AWS, so you cannot do multi-cloud. You cannot do multi-clouding. The documentation is quite overwhelming. Actually, they only have a GitHub page, which is quite long. I personally don't like it. It has no plugin support, so you need to stick with that what Zappa has to offer. And if you, like me, a guy for having YAML as your configuration format, then it's quite difficult or it's a manual effort to use YAML instead of JSON. And after the removal, it's not removing the S3 bucket for you. So that concludes my talk. So we can clearly see a new shift towards serverless architecture. And with those frameworks, you have a good starting point to use serverless framework, to use serverless application. But it's not just only those frameworks which helps you to run a serverless function. No, there are other serverless tools, for example, like monitoring or your cost explorer. So there's a whole new ecosystem which are built thanks to serverless. Still, you should think that servers are still there. They're not out of the way, but you have less frictions to configure your server. With serverless, you have a new DevOps culture. Operational tasks and dev tasks are coming closer, but it depends on the use case. Not everything is solvable via function. For example, I wanted to try a machine learning function using serverless. So it was like an image recognition, which where I paste the URL of this image into the function, and it should recognize whether it's a cat or a dog or what kind of animal. And it was not possible because I was running in several times timeouts, or the library was too big, and it was kind of cumbersome, but it's written in the blog post, which I mentioned earlier. Or you don't like the way, or you want to manage your servers or infrastructure, or you need to have to. So, for example, I'm thinking of some regulated markets where you need to have where you need to where it's not allowed to put sensible data into the cloud, where you have like an on-premise server and put there the data. Yeah, with that regards, I would like to thank you. Thanks for listening. And yeah, I'm open for any questions. Thank you.